being that patient. Thank you for being that cooperative. And since it is raining heavily outside, but still you made it to this evening, this calls for a big round of applause for yourself. Everybody, can we put a big hand for ourselves? Wonderful. Okay, so once again, on behalf of APL Apollo, I would like to welcome you all to this beautiful evening, wherein we're going to talk about something new today, something innovative, and something which is surely going to redefine the landscape of construction in India. Well, yes, today is all about NAYI SOCH, the next gen steel building solutions. APL Apollo, India's largest producer of structural steel tubes, has now come up with steel building solutions for the construction industry. Its high diameter tubes are now being used for construction, making the construction smoother for you and of course faster for you. No more dust clouds, no wastage of water, or I should say, let's join our hands to make the construction environment friendly too. Now, you may ask how. Well, why? This is the reason we have gathered here.
Civil works, tubes get processed, fabricated, connectors get welded, and then the material goes on site, it reaches for erection. That's how we achieve the speed of 8 to 9 days per slab. So one of the reasons, after interaction with a lot of friends in the industry, we figured out that there are like 5 reasons why designers from structural world, they don't like to put more tubes in their designs. The reason is that non-availability of larger sizes, which are required for high-rise buildings, limited size range, large MOQs which tube companies ask from the contractors, from the developers, which makes the consumption of tube a bit difficult. High lead time as well, and wastage in tubes, which the fabricators have to carry cost. So at APL Apollo, we have tried to work on all these concerns and trying to address these, so that the steel construction, the tubular construction becomes more beneficial to everyone. Now the applications, what we have seen, what we're trying to promote is for any kind of high-rise structure, whether hospitals, housing, schools, courts, hotels, malls, offices, many large developers are present here. We have people from Warehousing Association of India also support warehouses, food parks, cold storages, factory structures, process buildings. For all these buildings, tubes are beneficial. Aviation hangars, many fabricators here are working with the Airport Authority of India for hangars, and the very upcoming field, which is data centers. So steel tube versus conventional RCC. This is the working where how we save time, how we save cost. There is already a proof of concept here, which shows that a steel building, tube building can be constructed on 8-day per slab timeline, versus in RCC, which varies from 20 to 30 days depending on the complexity of the infrastructure. I'm sure there would be some exclusive projects where RCC contractors must have achieved high speed, but that's like very rare. We are taking average. You save 16 days per slab, it's a high-rise 15-story, you save 365 days, and then it can benefit you in terms of high carpet area. Your project will start early, which will boost your internal rate of returns. So project becomes more financial viable. And against that, what we pay today, $3 per square foot cost, which is like 250 rupees per square foot. Against that, if we factor in 2% additional carpet area, that will nullify the additional cost at just one go. So these are the benefits. Like construction time for superstructure gets reduced by up to 30 to 50%. The project cost will be low if you build in the building gets handed over early with early commencement of project, whether it's hospital, hotel, mall, or office tower. It lowers the financial cost, finance cost. We get the advancement of cash flows, better IRRs. Project is environmental friendly. It doesn't add dust in the air, which adds to the air pollution. It doesn't consume groundwater, which leads to the depletion of groundwater levels, which Indian cities are facing right now. There is recyclability factor in steel. After 50 years, 100 years, you can disassemble the welding and benefit from the recyclability. Strength is superior, resistance, seismic loading is better, so that's another benefit. And we have seen, we have done case studies where we also get the extra clear height up to 6%. So again, NAYI SOCH is the theme here for tonight. The next NAYI SOCH is environment, which anyone is talking about, whether it's private or government. So it's a global study which suggests that because of the recyclability of steel versus RCC, the construction sector contributes almost 30% to the direct carbon emissions, and that's why globally government construction agencies are promoting steel construction. And again, it's a proven fact that replacing reinforced concrete with steel structure can reduce emission by up to 60%. This is the cost comparison which I was talking about, 250 rupees per square foot. So these are the main. So this is like for skeleton of the building, right? So there are like six to seven factors: concrete, reinforced shuttering, structural steel, deck sheet, which takes care of flooring, shear studs, and fire intumescent paint, which is very important factor in steel buildings. So this is tubular, steel tubular. This is RCC. Concrete is there in steel because we use concrete fill tubes. We have super specialist, super expert from IIT Hyderabad, Professor Madhavan, who's going to talk about concrete fill tubes soon. And we put reinforced some shuttering. You don't need shuttering, structural steel, deck sheet, shear studs, and like RCC structure could be 825 rupees per square foot, and steel is 1,075. So that's the 250 rupees per square foot gap. Against that, benefits are like straight away in India, the average real estate price is 10,000 rupees per square foot. You get 2% extra saleable area, carpet area. You nullify that cost on day one. The other SOCH, what we have here is how to make steel construction better, how to make steel EE better. Built-up sections are being used for ages. We have Empire State Building, which was beautifully 100 years ago, all on built-up. But how do we better this? How do we come up with something new? So what we are trying to propose is that if the structure is 100% tubular, again we have seen that the project could be done 20% faster. The lead time for supply of tubes is much lower than making built-up sections by multiple fabricators. The connections, designs, some of the designs are here. We are doing a lot of research. We have used these designs on live projects as well. So connections are easy. The project costs come down. Again, for a beam, for a built-up section, you need to shutter it, you need to encapsulate it. In tube, we can get away with that. So carpet area again gets added here. And the more benefit is less consumption of steel, right? There are many live examples and case studies which suggest that doing a steel structure on tubes versus built up, we can save up to 5% to 20% steel. And tubes anyways are better for large span structures, and we get extra clear height even tube versus PE. So this is one case study which we did where we have taken examples of multiple grades, right? Where there is like width 30 meter, height 5.85 meter, and then so that's the clear span, and we have taken wind speed, truss weight, column weight, and we can see that in tubular the weight which is coming is like frame weight is 12,000 kg versus on PE the same parameters it's like 15.891. These are some myths. What our fraternity has in its mind. So we have also tried to address all those myths about tubular construction. So one myth is that the bolted connections are difficult, but it's not the case. We have a live example of these connection plates, connectors which are used in live projects. Then raw material cost is high. Yes, I mean when you compare tube versus steel plate, it will be high. But then the fabrication cost gets reduced, and ultimately on per kg basis also the cost will come down. Non-availability of large sizes sections, yes, but in last 4 or 5 years, companies like APL APOLLO Tubes have worked quite aggressively to come up with larger size sections and make them available for the contractors. Then the myth is that you need on-site fabrication. It's not correct. We have our friend from Assam, India, who recently executed 25 lakh square foot of 7 hospital projects in Delhi, and they can tell that 15,000 ton of structural steel was fabricated, and like hardly 1% of that was on site. Then the wastage of material is high. That's another reason why fabricators shy away from using tubes. But at APL APOLLO, we send cut to length sizes to the fabricator. So if the design requirement is 4.5 meter, 7.2 meter, 8.9 meter, whatever, we're going to cut the tube up to that size and deliver to the fabricator. And I don't know why my team has put this. Tubes are actually boring, but no. I mean, in fact, architects use tubes for improving the aesthetics of the building, whether it's airport or railway station. So this is one case study of the warehouse. I showed you the metrics already. This is in detail that a steel tube structure versus a built-up structure, we can save up to like 20% weight in a simple warehouse building with length of 105 meter, clear span 35 meters, and clear height of 9 meters. We have many such case studies. We'll be happy to share with you later on. This is the same matrix for G+11 story building. Again, we'll see that the weight of the structure for like 6.3 meter by 6.3 meter grid in tube it is coming 6 tons, and here it is coming 7.3 tons. 8.3 meter grid, 11.7 tons, and 13.2. 10.3 meter by 10.3 meter grid. Again, tubes are showing better results. So there's clear saving of 10% even in high-rise structures. And then the other benefits are high carpet area, because a built-up section you need to shutter it, you need to encapsulate it. In tubes you can get away with that. You can build a carpet area. Now this is what we are really proud about, and the reason why we requested every one of you to visit us, because with that conviction, with that confidence that yes, it can be done, we have done this. 7 hospital buildings, 6 sites which were given to the contractor, Sam India. 2.5 million square foot, 15,000 ton of steel work done in average 90 days. When we calculate the fabrication drawings were finalized, within 90 days, 15,000 ton of steel was manufactured, dispatched to the fabricators, fabricated and erected on site. This is 700,000 square foot hospital in the Shah Garden. Another site, 600,000 square foot in Shalimar Bagh. Sultanpuri, 300,000 square foot. Gita Colony, 250,000 square foot. Sarita Vihar, 150,000 square foot. I'm sure Mr. Karan Agarwal from Sam India will take you through the journey of this and share his experience. Now we are working for a lot many other structures, whether it is hotel or night shelters or office towers. We have our friend from Supertech, Mr. Khanna, who recently got a G+ 15-story building in Noida on Tubes. So the work is yet to start. I'm sure they'll be happy to share their experience on the same. Group housing projects also we are doing. One case study again to strengthen our viewpoint that was like built up versus tubes. This was like 13,000 square foot oxygen shed building, which was done in like 15 days. Mr. Jitendra Chok from Fab India did that, and he's present as well. Like I said, our friend from warehousing fraternity are here, so I want to tell them that many architects who are doing multiple warehousing projects or industrial shed buildings. This is a 80,000 square foot building in Delhi. I welcome anyone to go and visit. It's like 15-ton crane which is also being run, and it's all tubular, whether it's columns or truss, everything tubular. This is 350,000 square foot industrial shed building in Raipur. It has 30-ton crane which is running. Now the key is how do we achieve 8 days per slab timeline. These are the multiple activities what need to be done: site mobilization, fabrication, material, erection of columns, main beams erection, third and second floor, main beams erection at first floor, secondary beams erection, fixing of deck sheet, and concreting on second and third floor. Done in 8 days. So that's how we achieve speed. That's how we move ahead with NAYI SOCH. This is also very important. What factors need to be taken care of to achieve such speed? Architectural drawings need to be finalized, approved. Structural drawings need to be approved. Shop drawings need to be approved. Proper disbursement of funds for the contractor to quick start the construction. All clearances from government or local body, but that's required for RCC as well. And clear and ready site to start the work again. This we need in RCC as well. So while talking to our friends, we get this question every time that why in India we don't have so many buildings. Why it's like so new. So we tell them that yes, India is new. But globally, this concept is very much popular, very much proven. In India also, contractors like NT have done that in Mumbai, which are like massive high-story towers. Then in Sydney, Australia, then New York, the Hearst Tower, then DRDO building, which LNT did, was on CFT. In China, there are buildings of up to 70 story, right? And then all the aesthetically good buildings. Dr. Anubhav Gupta, our friend from Skeleton, he has done a group housing project in Jammu, all on tubes. And then again China, another 70-story tower, and London, which is like more aesthetically pleasing city, they have also used tubes to make their buildings beautiful. And why in India we don't see much of these examples like how we see outside India? So I guess that 250 rupees per square foot extra cost, which everyone calculates, right? So and India is a price sensitive market, so people shy away from going on steel. In India, project deadline doesn't matter much. We know that developers and contractors, they keep on delaying their projects. There is not very harsh penalty for the industry. RCC work can be done with unskilled labor, but in steel you need skilled labor. India is the second largest producer of cement in India, so availability of cement makes easier for contractors to go on cement RCC. Last section, tubes are also not available easily, so another factor which stops contractors from using steel. And high grade steel also. Before we started this presentation, I was having a chat with Professor Madhavan from IIT Hyderabad. So he was insisting that we have to take a quantum leap now to talk about not 350, not 450, not 550, but 690 grade steel. So I'm sure with such visionary outlook from friends like Professor Madhavan, I'm sure we're going to take that leap soon. And also, I mean, not many contractors carry expertise of quality engineering and workmanship, but I can proudly say that there are PV contractors in this very room who are capable of doing very good work on steel structures. So yes, I mean, we have been using tubes for so many projects, whether airports, refineries, or stadiums. But yes, I mean, let's work towards making even high-rise buildings to be constructed in a better way. This is APL APOLLO. We're the largest structural steel tube company with 55% market share. We buy 2.5% of India's steel every year. So all the innovation work, what we have done in steel, we are the first company to start producing square and rectangular tube sections. We are the first company to produce pre-galvanized tubes in India. We are the first company to produce direct forming technology to produce tubes in India. We are the first company to work on heavy structural sections, 300 mm square, which we started producing 5 years ago. We are the first company to produce world's first ever narrow and thicker color coated sheet up to 3.2 mm. We are the first company to have done first tubular company, first tubular building in the world, which are these hospital projects in India, and then first company to produce 500 square and 1000 mm square tubes. These are our sections which are like which are used for these structures. And with this NAYI SOCH of saving environment and helping our governments to save trees, all our products are designed, are manufactured to save trees in some way. Yes, so that's it from APL APOLLO. Thanks everyone for being a patient listener. Priyanka, may we have next guest announcement, please? Thank you.
Well, thank you so much, Mr. Gupta. With this, we're going to take this forward, and our next speaker, Professor Mahendra Kumar Madhavan from IIT Hyderabad. Well, he's responsible for structural steel related courses at both undergraduate and postgraduate levels. Professor Madhavan is also an experienced structural engineer with years of industry experience working on a variety of complex real-world problems that occur in the power industry. After completing his PhD in 2005, Professor Madhavan started his career at Alabama Power Company, Birmingham, USA, and worked there for a period of 7 years. He has published close to 50 peer-reviewed internationally reputed journals and more than 40 conference proceedings, and hold membership in the American Society of Civil Engineers, Structural Engineering Institute, Technical Administrative Committee on Metals, and ASC's SEI Gold Formed Steel Members Committee. He is an editorial board member of the Journal of Structures and an associate editor for the ASCE Journal of Structural Engineering. Professor Madhavan is also the first person from India to be elected as a fellow of ASCE Structural Engineering Institute. Ladies and gentlemen, please put your hands together and join me in welcoming from IIT Hyderabad, Professor Mahendra Kumar Madhavan.
Thank you so much for the nice introduction, and just before I start the presentation, I want to clarify I'm not a super expert on tubular structures. I'm beginning to understand, but a little bit knowledgeable. So I will share my knowledge. And so a few days back, I got a call from Apollo Tubes to give a presentation. Coming from Hyderabad, actually it was nice because Apollo is something a household name in Hyderabad because Apollo Hospitals is headquartered in Hyderabad. So the moment I got a call from Apollo Tubes, I said, okay, let me come. And I just made a presentation, share a few thoughts. I just move around a little bit, so that's why I call my, it's habitual for people in the faculty, the teaching faculty. So, so just these are not something, just a few thoughts, just like, let me give you my thoughts on. So, one thing that usually people tell is that, when we talk about composite structures, we always tell that what is the greatest marriage in structural engineering? The greatest marriage in structural engineering is between steel and concrete. And many people don't know why it is. And it is because simply the coefficient of thermal expansion for steel and the coefficient for thermal expansion for concrete is more or less the same. So for a successful marriage, you need compatibility. So for a successful structure, you need both the steel and concrete to work together. So what does composite structures do? Composite structures takes the advantage of steel as well as the advantage of concrete and then mixes together so that we get the best of both worlds. Right? Steel is good in tension and concrete is good in compression, so we take advantage of the two. So this is how my presentation will go. Just introduction, materials and components, application, a little bit of connections, economical benefit, and then talk about fire performance, which is the important thing right now. So composite members, so when you look at composite members, so basically there are two load-carrying members that are integrally connected and reflect as a single unit. So what you see on the left side is a composite beam, and then on the right side is a non-composite beam. It looks same, but if you look at it, when you load the structure, there will be a slip on the non-composite beam, where there will not be any slip on the composite beam. So that's the major difference. So compatibility is established in a composite beam, whereas slip occurs in a non-composite beam. So as I told you, you have a tubular structure, and you add concrete to that, and then what you get is a composite tubular structure. And concrete, what does actually concrete do? And what does steel? Why can't we just use a tubular structure? Why do we need to fill in concrete? right? That's a major question. Can we make it light by not pulling it? Why we should have concrete in it? The major reason that we have concrete in it is simply to prevent what is known as local buckling. So you want to reduce the quantity of steel, right? You want to make the sizes bigger. But then if you don't put something in it, there is a possibility that it could buckle inwards, which is, we call it as local buckling. So in order to prevent local buckling, if you add a material, okay, which is concrete, for example, it will add strength, but at the same time, it will prevent the formation of local buckling, which is an undesirable failure mode. What we need to achieve is failure complete ultimate load capacity that we need to achieve. So local buckling is one such phenomena where it will erode the strength. So the good thing is that we have to reduce local buckling. Another important thing about concrete is that it acts as a heat sink. So when you have a tubular structure and the structure is subjected to fire, for example, steel tubes don't have a chance. It's a very good conductor of heat, so the failure of the structure. This is some schematic view of how a concrete would be placed for pumping. So you can have a steel tube and you can put a tube at the bottom and you can pump the concrete up at the top, and that needs self-consolidating concrete. But on the right side, you put it from the top, it is gravity filling. Here you have certain challenges. You have to put a vibrator also. Self-consolidating concrete usually does not need a vibrator. Here you put it in batches of 300 to 500 mm, but you should have a vibrator, and the vibrator has to be little bit inside, at least 50 to 100 mm to vibrate the structure so that it gets compacted. Component behavior, the most useful component is a tubular structure from a strength point of view, but little bit challenges are associated with connections when you do a circular tubular section. But from a strength point of view, circular tubular sections are very good. But when we talk about connections as well as other aesthetics, I think the square as well as circular hollow sections actually are much higher. And the confinement is provided in the steel tube is much higher, so the load carrying capacity simply because of the nature of the geometry is much higher in a circular tubular section. And this is how this failure mode would look like. So if you look at the steel tube, it has both inward buckling and outward buckling. This is what I call it as local buckling. When I introduced the topic, right, I just talked about local buckling. So I just move once in a while because I was told that if you move this way, people don't sleep. Okay. When I teach a class of 20 to 30, it is a class. When it is more than 50, it's a performance. So, right? So you have this inward and outward buckling. This is a steel structure, steel tubular structure, but if you have a regular concrete, then you have this crack and crushing that takes place at 45 degrees. But when you add the two together, you drastically reduce your inward buckling. The only possibility is an outward buckling, so it is a much improved failure mechanism simply by adding concrete. Okay. So this does the same thing. And this graph is a fantastic graph. So you see on the left side, it is a steel tubular section. This is a real example done by a professor called Li Hai-Han, a friend of mine. He is in Tsinghua University in China, one of the leading universities. So the steel tube here, you have 729 kilonewton, and then if you have an RC structure, is 1192. If you simply add the two together, right, you get 1921 kilonewton. But if you add the two and put it inside, right, you get a load carrying capacity of 2017. So the load capacity increases. But that's not the moral of the story. The moral of the story is when you put steel tube filled with concrete, your ductility is very, very, very high. It's not working, so I just go here and so you can see that the ductility is very high. Right? So if you have a concrete, it feels like this. If you have a steel, it feels like this. You just add the two graphs together, something comes like this. But you infill, you can see a tremendous increase in ductility. Why is ductility so important? Because that is the only weapon that we have to prevent structures against seismic effects. Right? See, our nation in 1970 had 5 different seismic zones. 6, I would say. Zone 0, 1, 2, 3, 4, and 5. And then somewhere down the line we said we will discard zone 0, 1, 2, 3, 4, and 5. And then we said 2 also ho gaya. Okay, 1, 2. Now we have 3, 4, and 5. So we have low seismic, mid seismic, high seismic. right? So we cannot escape seismic. We have to design every structure because some level of seismic activity is bound to happen because our plate tectonic movement have happened in such a way that we have to design for seismic. So we cannot run away from the problem. We have to confront it and we have to solve it. And the only equipment that we have, or the only solution that we have, I would say today, is tubular sections with concrete infill. And this again gives you, when it is subjected to tension, so it's steel tube, and you have this crack happening here at the center, but it's a big crack. But when you fill it with concrete, you have micro cracks. So the member is, fails in a ductile manner. When the member fails in a ductile manner, it is a desirable failure mode. And then when you have bending, what happens? Then there is an inward buckling at the top. But then that is a simple steel tube. But if you have concrete, it has a lot of cracks and crushing happens. But if you infill it with concrete, okay, what happens is that there is only small outward buckling, but at several locations. So it is the failure is sort of distributed, uniformly distributed, not a catastrophic one, which is again saying it's a desirable mode of failure. And then we subject it to torsion. Again, this is not going to resist very well. The first one, the second one, and also having cracks. But when you put it inside a steel tube and you are trying to twist it, okay, you have much higher resistance against torsion for an infill concrete. Earthquake resistance, you see the figure, you will quickly understand this is what the seismic force as well as the deformation that takes place. This is for concrete. But if you fill it at CFST, infill concrete, you have so much of deformation capacity. What does deformation capacity tells you? Boy, the structure is going to fail, you better run out of the building. So it gives enough failure, enough distress, so that we understand that something bad is going to happen, and that is the beauty of steel structures. It's the inherent nature of steel structures that gives you the ductility. The infill concrete with steel gives you this ability to have an improved deformation capacity. So after having that, what are the application of CFST? Usually it's the main columns in subway stations. That is when I think the CFD structures became more popular. Actually, what does it do? Because in an underground subway stations, the size does matter, because in subway stations you have more space for the trains to go, not for the columns to occupy. The strength of the structure is important, but the functionality of the structure is more important than the strength, right? So you need to have more functionality. So reducing the size of the columns becomes a challenge. So they went for tubular structures filled with concrete in most of the subway stations. This will be common in most developed countries, like in Singapore. A lot of underground subway stations are there. And you look at New York, for example, will have a lot of subways. London, all these things, they use a lot of tubular structures. Workshops and power plant buildings, they need more land space. Again, high-rise buildings, multi-story columns and beams, okay, they all have industrial structure and tubular structures. Now, this is very much used for bridges. Bridges are picking up in India, and tubular structures is the key to achieving large span structures. And this is another application, especially in China. They have taken it to another level, because a lot of transmission towers in China, they use these tubular structures filled with concrete. We also have these kind of structures, especially if you are in Hyderabad and coming to airport, you will see a lot of these tubular structures, but they are not infilled with concrete. They are just dummy tubular structures. So the sizes are huge. The objective is to reduce the use of steel, reduce the use of concrete, but still be able to achieve what we wanted to achieve. By infilling concrete inside a steel tube does wonders for us. And this is a nice building in London, just to show some pictures. And this is again a tall structure in China. Okay, we have a long way to go, boss. Next door neighbor is doing a lot of structures, things in tubular structures in general. So it's time that we gear up and start moving as a nation. Also, this is again in London. Nice buildings. I think Mr. Gupta actually showed this building, but this is independent research of mine. So this is again a CFST tube that is very nicely done in arch, bridge kind of structure where they filled it up with steel tubes. These are all things that are done in the factory, brought it to the site, and then it is bolted together, and it gives a very nice neat appearance. In fact, if you look at it, bridges are very iconic. It's not being biased towards anything. When you look at a bridge, if it is done well, it becomes a signature of a city. You look at, say for example, if you anybody telling about San Francisco, the immediately that comes to their mind is Golden Gate Bridge, right? So now in Mumbai, they have done the bridge, right? They just put the bridge picture. So bridges are interesting structures, and to achieve large span structures, I think we should use tubular structures. This is one of the tallest tubular bridge structure. I think the world's highest bridge piers of concrete-filled tubular ladders. That's in China. So let's talk about some, hi-fi stuff like coding provisions. Okay. So the first thing that was done was in 1967, based on the research. Again, I move forward just to make sure that you're all not sleeping. Sorry. So it was done in 1960s with the Japanese. Okay, it was published in Japan, 1967, by the Architectural Institute of Japan. So when you think about architecture, don't think about the architecture in India. In Indian architecture, the fellow will not touch structures even with his left hand. But in Japan, all buildings come under architecture. All non-buildings, bridges, towers and other things come under structural engineering. So the Department of Civil Engineering has a structural engineering which will do everything, okay, except buildings. Okay, the Department of Architecture also does the structural engineering, but they are focused only on buildings. So architecture in Japan means a little different. Then there is something called SSRC, the Structural Stability Council. They came up with a code in '79. These are some of the codes. AIC 2010, British code is there, Australian code is there. Of course, British code is now not very effective. It has been morphed into what is known as Eurocode, and Chinese code is there. And last but not the least, we have a long ways to go. Tubular structures code is also there, but R&D has to be done significantly into the technical content of the code. This is gory details. Okay, apologize, forgive, sorry. Okay, but still, this is how you do things. Okay, circular section, rectangular section. Just to understand, So what it does, gist of it is, the strength comes from three components. One is the steel tube, one is the infill concrete, and inside the infill concrete, if you put a rebar, that also adds strength. A plus B plus C is the total strength. That is all they are saying by adding this. So this is steel, this is concrete. Since we are not talking about rebar inside, I neglected the term. So you add these two together. Okay. And why is it 0.85 for rectangular and the same thing is 0.9 for circular? Because circular is better in resisting the local buckling. So the code inherently recognizes that and gives an additional 5% discount for people who are using circular sections. That's the okay. So this is all the gist of it, but it's all available. Okay, in the code. I didn't do anything new. I just put it together. Okay, this is how you design it, but nothing fancy. You just put it in an Excel sheet. 10th grade fellow can put it. What is most important is not to do all these calculations, but just to have a general view of, is it making sense? Am I doing the right thing? What is wrong? Is it something connections, or am I putting the concrete correctly? Is the strength the problem? The thickness the problem? Slenderness the problem? That kind of intellectual thinking is more important than running day-to-day things. I do understand that design offices run production basis, but it's equally important for you to understand the basics of the philosophy behind these things. Again, this is for BS code, same thing. But they have, rather than this thing, they say circular as well as non-circular. Here they have these three components: steel component, concrete component, as well as the rebar component that they have there. Okay, and they have all these equations that they plug it into. Okay. Again, this is for another thing called simplified method. So this apparently is a complex method. So they came up with the simplified method. It's all the same, but if you ignore the right side of the portion, this is just the checks. This should be familiar to all of you because this is a regular steel design, IS 800 type of structure. Okay, so what you see on the right side is just the jugglery that you have to do in order to make sure that it works there. But on the right, on the left side, what you see is day to day. Just P factors, stress reduction factors, lambda factors, and this is an imperfection factor. Alpha is an imperfection factor. Okay, this is a slenderness ratio. This is a P factor, and this is the reduction factor that you multiply by using stress. So again, I don't want to go into the details because I didn't know that I was given only 15 minutes time. So sometimes I tell my people I'm worse than a politician. If you get a mic, I will not come out. So I just want to show you that it's not that difficult. It's just something that you can do it very quickly if you know the basics of it. And you just do all these things. And then you say that this is what it is, major axis slenderness, minor axis slenderness. And then put it here like this, okay. And there you go. Yes. And this is where the Eurocode comes into picture. You have a circular section, then you have this code, and then they say that the imperfection factor is alpha is 0.21 because it says that it should be 0.21 buckling curve. So you put it there, get the side, voila, you get it done. So with this one, I just want to go into the connections. Connections are three types: rigid, semi-rigid, and flexible. Simple connection, and then it just transfers the forces, but not the bending. Semi-rigid, sort of what we call Grisanko. Some amount of rigidity is there, some amount of internal forces is there. Rigid connection completely withstand the moment, perfect angle between the two members. So what you see here is the one is the simple connection. Okay, this is the semi-rigid connection. This is the rigid connection. But just for your information, rigid connection is also not truly rigid. If you can achieve 90% rigidity as per American standards, it's rigid. You're almost there. So you don't look for 99.9% accuracy. If you're more than 90%, they classify it as rigid. So these are the simple connections that you can see. This is the what we call it the spring plate. So you attach the spring plate here. So then that is the yellow color stuff that you see here, and then you have an I section that is attached to that, and then this is how you make the connection. And then this is simple beam to column connection. Connections are very, very important, my friends. Okay, very, very important. If you know how to do connections, I think you will be a very good structural engineer because you need a little bit of understanding of everything. Members rarely do fail. The failure usually starts with connection. When the connection fails, it does not fail by itself. You bring 2 or 3 members together along with it. So that's the problem with connections. So dealing with connections is extremely important. These are some of the details of the connection. Several ways of spinning a cap. You can have, 2 angle sections, and you put a tab there, and then you can connect it. These are simple connections, or you can put a welded fin plate, as you can see here, this one shear plate connection. And then you can have a T section welded, then you can also have a connection like this, through plate connection. So several different types of connections. The moment connections are something like this. Okay, most of the time the connections are something that you cannot do simply by hand calculations. You should also have some kind of a testing that has to be done usually. These are some of the details of rigid connection. Okay, economical benefit of CFS, this is just some type of thing. I think Mr. Gupta had already talked a lot about it. But I just wanted to give you a brief feel for it. Actually, the cement consumed is much lesser, the concrete consumed is much lesser, and the strength is very good. So, this is another building. The average RC column section sizes are reduced, which means that your real estate space is more to sell. Weight is lighter, so you attract lesser load due to seismic effects. Okay. The cost of formwork, manpower, erecting, stripping of formwork can be saved. Okay. And most importantly, the most difficult thing in a RC construction site, I don't know if you really know that, is to protect your formwork from getting stolen. A lot of formwork gets stolen because it's steel, right? So they use that. So when they strip the formwork and keep it in place, Some people come in a truck and they say that they have been asked by a contractor to pick it up and then take it, and then the next day the real contractor comes and says that where is my formwork? It's all gone. So formwork, taking care of formwork is also a full-time job. So again, the same story repeating. Okay, I just want to give you more info on these things. This is more important. Reduce, reuse, recycle. Okay, green. So there are active ways of doing that. There are passive ways of protecting it. This is a spray and a cement mortar, which is very common. 2 years back, I was in Japan for this prior to COVID, just 2-3 months before COVID. I was taken for a tour of the new steel structural buildings that were built for this Olympic, which got postponed, I believe. It was supposed to happen in 2020. Fabulous work, fabulous work. Okay, but when I looked at it, this is what they have used. They just used the sprays and cement mortar to act as a fire protection mechanism. Okay, intumescent coating, the structure that I currently, my office is in a building which has intumescent fire coating. So what is intumescent fire coating? I don't know, perhaps everybody knows it or not. It's very similar to what you have in an airbag in a car. Impact, right? Sudden impact, it blows, right? It just gives a space. Same thing happens in intumescent paint. When you get heated, the thickness of the intumescent paint increases by 50 times. When it increases by 50 times, it reduces the amount of heat that would be absorbed by the steel structure by providing a protective, safe net, I would say. Okay. Again, gory details. Test results show that by providing the intumescent paints and other things, you can simply increase the fire rating. Okay, thank you.
So that was a detailed study though, yeah? Thanks for imparting that knowledge to us. Can we all please put our hands together for Professor one more time? Okay, so with this, we're going to take this forward, and our next speaker for the evening is Mr. Karan Agarwal. Mr. Karan Agarwal, Director of Assam India with 17 years of experience in different construction sectors from business function to general enterprise management. An individual who's passionate about building sustainable buildings, winning customers who are investors, and have history of managing the complexity, diversity, and unlocking the true value of building lines. He believes that success is all hard work, perseverance, and honesty. In a world that is increasingly relying on complex strategies, long-drawn discussions, few people have managed to keep it simple. He emphasizes on seemingly simple and old-school rules. Innovations, big ideas, being different, all have a place, and sometimes that can be very important. We alone shape our own destiny with the vision and mission of our company. Talking about his company, Assam India. Assam India Buildwell Private Limited takes pride in being one of the pioneering engineering and contracting firms in India, with a centralized office at New Delhi, and has achieved a remarkable growth over the last 2 decades, while contributing significantly to the development of the nation. The company has attained prominence as a distinguished player in the field of construction and engineering through competence, competitiveness, and timely delivery with highest quality standards and recognized safety performance, and all set for successful competition with international players. The company, who has successfully executed many prestigious projects including metro stations, depots, hospitals, airports, multi-story housing, international highways, township, and more. Please put your hands together and join me in welcoming Mr. Karan Agarwal.
We've been building existing since the dawn of humanity. For thousands of years, we've evolved to build bigger. Now comes the next revolution in construction technology. APL APOLLO Steel Building Solutions for better and faster construction. Recently used to build a hospital structure in just 150 days. PWD planned 5 hospitals last year. Structural work at all the sites is almost done. The 1900 plus bedded GTB hospital was the largest built away of more than 6 lakh square feet. Conventional construction technology would have been too time consuming. The pre-engineered steel tubes were selected to complete this challenging project in less time. 80 to 90% of the structure was built on 4 section sizes. Drywall and deck slabs were erected and cast on tubular steel structures. All steel fabrication work took place at fabricator workshops with zero on-site welding, only structure assembly with high-strength bolts. This was made possible only with APL APOLLO Steel Building Solutions. Thanks to tubular construction that offered the perfect balance of speed, quality, cost, and environmental friendliness. APL APOLLO Steel Building Solutions give you lower project times, easier execution, and structure optimization. APL APOLLO Steel Building Solutions, a true revolution for future construction.
Good evening, everyone. Thanks for this nice introduction. Let me start over. Already Priyanka has given us the brief introduction of my company. We started in 1998 and we are the pioneer contractors for the major PMCs in India, just like Delhi Metro, Mumbai Metro, Gujarat Metro, Uttar Pradesh Metro, Indian Railways, Airport Authority of India, CPWD, Defence, and NCRTC, which is the emerging PMC in India, which is connecting Delhi to Meerut, Delhi to Jaipur, and Delhi to Bhiwadi through metro. So we are connected with the pioneers of PMCs in India. And our main USP is that we deliver all the projects with a 97% is the successful rate we deliver. And the main punchline of our company is every time and before time. So let me share my experience in building these 5 hospitals with these pipes. So the future of smart buildings. I'll cover up the presentation in these 7 bullet points. Why we consider steel over RCC. Now, with the experience of completing these 6 hospitals in a record time of 150 days, we are in a better position to answer why steel is considered and preferred over RCC. What is the cost differential between PEB structures and tubular pipes? Why not so many buildings on steel in India? What's the difference between tubular and PEB? What are the benefits of tubes over PEB? How was the experience on working full tubular buildings? What speed could be achieved per slab? So, this is the question which we were also on doubtful mode before starting these 5 hospitals, which we started in the month of November 2021, sorry. So after completing these 5 structures in a span of 150 days, we can recommend any contractor, any builder, any establisher who wants to finish the building in a span of 9 to 12 months, irrespective of stories. The first best benefit what we felt after completing these hospitals were the speed. Steel structure speed is the fastest what we have accomplished in last so many years. The steel structure has more tensile strength than RCC structure in any case. Steel structures are more resistant to seismic and wind loads. Weight of steel structure is quite low as compared to RCC structure, which helps in reducing the foundation cost. This is the most important point, that it is actually giving a cost saving to any of the establishment who is going for a new construction. Then comes the RCC structures have low load carrying capacity compared with steel structures. The third part is the uniformity. Properties of steel do not change as opposed to concrete. Steel structure is portable and recyclable as well. Steel structure retains their value in comparison to RCC structures for coming 60-70 years. Recyclable. The significant nature of steel is that it is very well maybe reused the same number of times as one needs without losing any of its inherent properties. So after 50 years also, if we are getting bored of the design, we can demolish the building, we can recycle the steel, and then we can put the same steel into the new concept and the new design what we want to. So the recyclable is the best option which we won't get over RCC. The aesthetic appeal. Structure steel offers a stylish way of creating large column-free interiors and gives the building a sense of openness. Also, structural steel is malleable, so it gives the designers the freedom to explore ideas and create stylish textures and shapes in order to make the building look unique and beautiful. So we don't have to compromise with the exteriors and the interiors of the building. In steel structures, changes and additions can be made very easily whenever required. So it gives the flexibility to the architects, to the consultants, to the users to design the building as per their choice. Concrete structures require large number of workers to manufacture concrete, arrange reinforcements, formwork, shuttering, but steel constructions are more machine oriented and need less labor. Nowadays, we are struggling with the labors. Client is always behind our lives to complete the project before time or on time. The conventional buildings, still we are doing a lot of buildings for other departments which are conventional in nature. The main problem we face every day is the labor. The best part in completing these hospitals were we don't have a hue and cry for the labor, all were machine based. This is the cost what we have calculated after completing a tubular building versus a built up building. No doubt the built up sections available in India market is less priced than a tubular pipe. It's 10 rupees lesser than an MS tube, but if we go through all the heads, the material handling cost, inventory cost, fabrication cost is the best saving. Here we don't have to fabricate a tubular pipe because it is a ready-made pipe available in the market. We just have to cut the size, weld it with the beam, and product is manufactured. Wastage is also the important point. In built-up sections, the wastage starts from 5% and goes up to 20% depending upon the size and the shape. But here in the tubular sections, Mr. Anubhav Gupta has already apprised that they supply cut and length as per the requirement. So the wastage is zero. We have consumed around 16,000 metric tons of tubular pipes in hospitals. The wastage has come out around 0.2%. So the wastage part is significant which we are saving as compared to built-up sections. As far as erection is concerned, the cost remains the same. So overall we are saving 5.5 to 6% as compared to built-up sections. Second, speedy delivery. We haven't faced any problems as far as the availability of tubular pipes from Apollo. So the readily sections are easily available in the market. So as far as the speed is concerned, material is not a problem. The next question arises that why not so many buildings are still in India, steel buildings are not available in India. It's very common to see a public building with a structural steel in US and Europe. But in India, being the largest third producer of steel in India, still we don't have those many buildings in India. The main reason, the perception we all have till date is the cost. That being a steel building, it would be a costly affair as compared to RCC building. But now the perception is totally changed. If we talk about the cost with respect of time, we save 50% of time, and time is money. So as far as the time conscious clients, government, we can definitely say that a steel structure is definitely economical option as on date. Another reason that why we don't find so many buildings in India is the lack of awareness. Due to lack of connectivity with the technology, steel industries were unable to seek the adaptation, but now the steel industry has seen an adaptation of noble steel modular frame systems on construction sites. What's the difference between a tubular and a PV? Both sounds very common because both the structures are related to steel. But basically, PV is a pre-engineered building, tubular sections are also pre-engineered in their own way. But the difference is the material. Tubular is basically more towards hot rolled section and a square tubing, which is basically readily available in the market. You don't have to fabricate those tubular sections. Whereas a PV, it's basically a three-plate design all the way through the production of the steel. We have to cut the plate and we have to weld those plates to make the column. So this is the basic difference between tubular and PV. What are the benefits of tubes over PV? What we felt is lower steel consumption, hence lesser cost of project as compared with PV. Speedy construction and time saving in projects because of less fabrication, less welding is involved. Minimum wastage of tube due to tubes available in customized length. We don't have to waste any number of pipes as we want. It's available as per our own requirements, starting from 2 meters and goes up to 6 meters. It's very easy in erection at site and time saving as complete system is in on bolting. We are using high grade bolts and everything is on bolts. No welding is required at site. So this is the best part. Everything is ready in the factory. It is just like fixing a modular kitchen or a modular wardrobe in your house. Everything is fabricated, painted at factory premises, delivered at site and immediately erected. So there is no confusion of engineering. It is just the methodology we have to adapt. Tubular structures are aesthetically better and having more headroom height as compared with PV. Tubular steel sections are naturally strong, especially against longitudinal stress, which is why steel tubes are used in applications like scaffolding. Tubular comes with the high tensile strength, its elasticity and ductility, thus it does not break easily. So these are some benefits what we have felt. What was the experience on working full tubular buildings? So what we felt is tubes were supplied with less lead time. We have consumed around 15,000 of tubular pipes in less than 90 days. And all the material was supplied within a span of 65 to 75 days to our factory yard. So as far as the supply is concerned, supply is totally fantastic. Fabrication work is reduced drastically because there is no welding involved in manufacturing of these pipes, and zero wastage, burning and cutting loss is almost zero. Considerable reduction in fabrication cost because of the minimization of welding process. Maximum production 3,000 metric tons a day. What we have achieved in the process of 120 days in our factory, on a single day we have achieved 300 tons fabrication with these pipes with an average of 150 tons a day, which is not possible in any built-up design. It's very smooth surface, so after the paint it looks good. It's easy to erect with the help of cranes. Overall experience, as far as Sam India is concerned, it's very fast, cost effective, hassle free, amazing look and feel after the structure is erected. what speed could be achieved per slab. We have constructed six hospitals at 6 different locations in Delhi, comprising of 9,000 beds, with G plus 4 stories, carrying 5 stories. Total built-up area was constructed approximately 2.5 million in 150 days, with an average of 15,000 to 17,000 square feet slab is casted per day. If the same area needs to be constructed in any conventional building, then this 150 days is approximately the double or maybe thrice, maybe 300 days or maybe 450 days. It is not possible in any conventional building to achieve these targets. I will show you some pictures which will give you a better idea that how easy it is to erect the building in 150 days. This is the normal foundation process which every building will follow during the start. This is the first precise activity. We have to fix the anchor boards where the column will be erected and will be bolted in these anchor boards. Then the column which is being fabricated and painted in the factory premises is delivered at site, and then they are erected with the help of cranes. Then they are being tied with the beams, joist beams, secondary beams and main beams, and the structure with the help of cranes, with the better planning, we can erect 150 to 200 tons of steel every day. Then after the completion of structure, we will deploy the deck sheets, which is easily available in the market. Then a nominal reinforcement is put on the deck sheet. And then we pour the concrete and the floor is ready. This is how we can achieve a cycle of 8 days continuously with a better planning. This is my experience, what we have shared, and minded constructing a 25 lakh square feet in 150 days is not possible in RCC structure. It's only possible in steel tube pipes. We highly recommend everyone who is looking for a building in a lesser time, between a span of 8 to 9 months, we strongly recommend to go for tubular pipes. We have a fantastic experience in making these hospitals with tubular pipes. This is the hospital just completed in the month of April, GTB hospital, comprising of 650,000 square feet of area. All the slabs were laid and the top slab is in progress. After completing the structure, these are the finishing works. These are the wards where the beds, patient beds will be kept. So look and feel, after completing this structure, nobody can give you a hint of it that the building were constructed with the tubes. Interiors remain the same, exteriors remain the same. These are all the pictures after the completion of the structure. The main look and feel remains the same, whether it is RCC or steel pipes. This is from my end. Thank you.
Thanks so much, sir. With this, we're going to take this forward, and our next speaker for the evening is Mr. Dr. Vinod Jain. Dr. Vinod Jen, a renowned structural consultant in India who founded Vintech Consultants in 1988. He has completed his Masters and PhD in Structural Engineering from IIT Delhi. With numerous awards and fellow in multiple structural and civil engineering organizations, Dr. Jain is listed among the most prominent structural consultants in India. Talking about his company, Vintech Consultants, it's a 34-year-old consultancy that has completed more than 900 projects and 400 multi-story buildings. They employ a workforce of more than 100 personnel. They have designed structures more than 50 stories in steel and RC structures. Recently, they have acquired NAYI Consultants, which is another leading firm that is known to design multiple government projects and airports. Ladies and gentlemen, please put your hands together and join me in welcoming Dr. Jain on stage.
formatted. Thank you, Priyanka, for the good introduction, and good evening, everyone. First of all, I would like to thank APL Apollo and especially Mr. Anubhav Gupta for conducting such seminars for interaction. This is my great pleasure to deliver a lecture with such a great audience. Priyanka has already explained about our company, so I will skip this slide. I will just show some of our steel projects which we had recently designed and has been occupied also in last 5-7 years. This is Alpha Thumb at Noida. These are 3 towers, 33-story high, and connected at top. It is the longest swimming pool. Maybe in the world, or one of the longest swimming pool. This is Omex Chandni Chowk. It is almost, structure is almost finished, and architecture may also be, all finishings will be completed by October. So it was the demand of the site, because Chandni Chowk means it's so congested area, and steel was the only option which we had opted for that. This is Convention Center in Pragati Maidan. It houses about 5,000 people at a time, and we had consumed about 9,000 tons steel there, and structure is almost done, finishing is going on. This is a corporate office and showroom for Hyundai at Gurugram. It is occupied building, and spans and atrium is about 24 meter inside. This is Cyber Thumb for Botany Group at Noida. This is 200 meter high building and connected with a ball of 30 meter dia at 24th floor. This is corporate office for Resotech. It is a projection of about 20 meters, which is supported by tubular structure for 4 stories. This is South Point Mall. We had designed in 2005 for DLF. All facade is in tubular structure only. This is another project, H2O Tower in Greater Noida. This is also occupied building. It is IT Park in Film City in Noida, and it is done. It was with the precast slabs. The building is coming out by 6 meters in the center and then going again back. This is Trichy Airport. The whole roof is being constructed with tubular structure only, with 3.5 meter deep trusses, and we had consumed about 8,000 ton tubes. The structure is almost completed. This is Pune Airport. In this also the spans are like 36 meter or so, and the complete roof is with tubular structure only. This is Lucknow Airport. It is about 16 lakh square feet area, and we had consumed about 12,000 metric ton tubes. The complete structure, the roofing structure is with the tubes only. The spans are like 36 meter or so. This we are conceived at the moment cold storage in Shimla. The all columns are in tubes. It is just under construction. Now, today's topic is LNGP Hospital. The architect for this Sikka and Associates, the client is CPWD, and the contractors are Swadeshi Civil, and fabricators are Fab India. These are two multi-story high-rise towers. The area is about 12 lakh square feet.
That it has a rigid diaphragm and it will say that beam पे action force नहीं आएगा, but which is not true actually. So you have to design all your collector elements for that force. So the tube beam is a perfect solution for that. And also if you are having a high temperature stresses in your beam, in your building, and you are having long buildings where it can expand, it can contract, then it will have axial forces in those beams, and for anything which has axial return on it, or you have to resist buckling, go for tubes. That is the best solution. Right, thank you everyone.
Thank you so much. For this, we're moving ahead with the last session, and for the same, our next speaker is Mr. Akul Khanna. Akul Khanna, Director Supertech India, is a young entrepreneur and the second generation in the business, heading the sales and marketing functions of the company along with identifying new innovative ventures and collaborations. His dynamic approach has helped Supertech grow multi-fold in the past couple of years. Talking about his company, Supertech India, established in 1987 by Mr. Vinod Khanna, is one of the leading manufacturers and solution providers of steel buildings in India. With a very dynamic approach, Supertech has a very strong set of repeat clients with customer satisfaction being their utmost and topmost priority. Ladies and gentlemen, please join me in welcoming Mr. Akul Khanna.
Thank you for the great introduction. I'm Akul Khanna from Supertech India. We are a pre-engineered building manufacturer. We were established in 1987. And so not taking too much time, actually Mr. Gupta and Mr. Karan, they covered all the points which I really wanted to. So wouldn't take too much time from you. So these are certain projects showcasing. So that's a building we had done for GMR, which was leased out to a company called Saffron. That's a A-grade warehouse for a company called ESR Warehousing. That's another large warehouse which is almost 4 lakh square feet. We are doing for a company called SY Logistics. That's another factory building for a company called Avery Dennison. All of them pretty similar structures, industrial usage. The structure which we did for Avery Dennison, that's with a 60-meter clear span. So showing you some different structures which are of course done in PV. So that's the manufacturing unit which is G+2 floors for TVS Motors in Nalagarh. This has on the first, the complex part in this building was that the first mezzanine had a loading of 2.5 tons per square meter, which was, at that point in time, it was something which was very challenging from a design point of view. But finally it came out well. It was about 270,000 square feet, completed in a span of 5.5 months. On the next photo is a bridge we had done for a company called Vatika Developers. They are one of the leading developers in the north. So initially they had designed the building to actually, there was a walkway design between both the buildings which was just for people to walk, but finally they could get some extra FAR, and they wanted to construct this as leasable floors, which was definitely not possible in RCC because the span was upwards of 32 meters. It was almost 33 meters. So we could, using steel, we could design this structure. Another challenging thing was that we couldn't take any support from the bottom. It had to be a clear span structure.
because the road below this was not designed to be load bearing. So moving to the next, this is the International Cricket Stadium in Assam. This was 7,200 metric tons of steel. Initially, it was to be made in RCC, but then finally, because of the tight timelines, it was converted into steel. So this was a combination of box sections and I sections, as you can see. But these box sections were manufactured out of plates. So at that point in time, it was a big challenge as the production fell down by more than 50% because of the time taken to make this particular section. The next structure is a factory building, but of course not like a regular PEB what you see on a daily basis. It's a north light system. It's for a company called StoneX, so they wanted some stone aspect to be visible. So the sheeting was done in a tapered manner. So what I want to actually convey by showing these images is that as a steel building solution provider, we've done almost all structures from a guard room to a cricket stadium to large warehouses to petrol pump canopies, small, big, all of them put together. So when we got introduced to Apollo, and when it comes from us as a fabricator, as a steel building solution provider, I would talk about tubes from our perspective. So why steel tubes? So most of these points are covered, but I'll just quickly run through them from the perspective of a fabricator. So one is that it's a clean, neat look, which definitely in I sections there are too many areas where dust gets accumulated, so that gets saved with tubes. As Mr. Karan said, that there's major time saving on fabrication because the whole process of cutting the plate and then making it into an I-beam gets reduced, which takes a lot of time and of course a lot of handling of the material, wastages, etc. Steel tubes, I think it's a well-known fact that steel tubes definitely optimize the weight of steel used in the building. The only thing was that even designers were very for it that yes, let's use steel tubes, but when it came to the production part, they were like, sir, it will take too much time, it will, we won't find the right raw material, the availability of material is not very, it's not widely available. Overall cost reduction, wastage is a very, very big criteria. Of course, fabrication cost, yes. But with Apollo Steel providing cut-to-length sizes, we are able to bring down the wastage to less than 1%, which is also that 1% comes from the plates which are used to make the base plates of the tubes. So if I talk about tubes, it's literally 0%, apart from the fabrication cost decrease. Cut-to-length sizes available, of course, and customized section sizes available with Apollo coming in. That's a big, big advantage, and that will really take the use of steel tubes further. So I'm going to talk about a case study which basically so with Apollo we've been able to get a project which is ground plus 16 floors put together in Noida, which is going to be put to, it's going to be commercial use. And so this is just a view of the building. So this is the ETAP view of the building being done. So we were working on this inquiry for some time, and we had, so the developer, they had a specific requirement due to the Noida authority norms. They wanted completion pretty quickly because of, after that there would be penalties. So that's actually the reason why they went into steel. So we designed being a PEB manufacturer, we obviously designed this in I sections. So when Mr. Anubhav, he just showed us like the difference. So the steel structure, the tubular structure was about 1,050 rupees a square feet in comparison with the concrete structure being about 825 per square feet. When we designed it in I sections, it worked out to almost 1,250 rupees per square feet. So the difference of 15 to 20% went up to probably 50%. Which was a complete no from the cost perspective from the client. Secondly, apart from the cost, another problem which we faced was that so when we talk about warehouses or factory buildings, section sizes is no problem because it's generally 1 or 2 floors. There's no height restriction as such, so section sizes really don't make that big a difference. So high-rise buildings. So this was of course a commercial building, but even residential buildings have a maximum height restriction. So if your beam sizes are very large, you compromise on clear height of the floor, which is a big no-no because there is a minimum clear height required. So that was the other problem we were facing with I sections. But I was very keen on doing this project, ground plus 16 floors in steel in Noida on the expressway. So I was in touch with my design team. I asked them, what can we do to bring the tonnage down? They said, sir, आप पाइप में इसको डिजाइन करते हैं. तो मैं कहा करो. Said, sir, मैं तो डिजाइन कर दूंगा, but आप प्लांट से बात कर लो सर, वो शायद बनानी उनको बहुत टाइम लगेगा, उनको सेक्शन साइजेस में मिलेंगे. So when I spoke to the plant, they, as usual, they said sir बॉक्स सेक्शन बनवाओगे तो डबल ले लेना टाइम because productivity बहुत लॉस होगी and otherwise in pipes, even my designers who are from a PV background, they've been working and doing that in and out for years. Even they are not aware that Apollo is actually doing customized sizes and cut to length. That's when we got in touch with Apollo. They not only supported us in terms of confirming that yes, they will be helping us procure cut to length sizes pipes. They also provided a lot of design support in terms of how the structure can be optimized. We could bring down the tonnage from, in comparison with the I section to tubes by about 18%, which was a game changer. We could, so the mathematics which Mr. Anubhav shared that, about 18 to 20% more than concrete, we could achieve that and we got the project, and probably in the next conference I'll be sharing images of the finished building. So these were, the building is going to get completed in 6 months, which of course it cannot be done in RCC. The beam depth is much lesser. 2% more usable area, that was another very big factor for to convince the customer in going with tubes. The tonnage reduction was about 11 to 12% only in the columns and beams, and with now, since in this building we're using concrete filled tubes, so it went up to about 18%. And of course, no hassle of shuttering and de-shuttering, we're using a decking floor. And so compared to I section, another cost which was not calculated in our code, which was the encasing of the columns. So that's not being done, so by and by we could save the customer probably about 30% in comparison with the PEB section or built-up section is what we call it. So that's it from my side. Thank you so much for patient hearing. Thank you.
Thanks so much, Mr. Khanna. With this, this brings us to the end of our evening of this conversation which we had regarding the NAYI SOCH, the next gen steel. So, ladies and gentlemen, with this, we are almost near to the end over here, but we would like to open the Q&A session for you guys in case you have any question to be raised. We have a fellow people to answer it. Anyone?
boards, harbors, docks. Whether this type of skills may be used in that region where the atmosphere or environment is alive.
Yes, hi. So there are two things. One is that if the steel is exposed outside, then anyways there's going to be fire retardant paint coating over it up to like 2000 microns. So that does take care of rusting. And anyways, if it is not exposed, so there will be light paint over it. So these kind of fire coatings, fire resistant coatings also prevents rusting in steel structures.
Okay, anyone else? Do you have any other question?
Professor Madhavan will like to add to it, please.
Just to clarify, the tubular structures is very, very common in offshore industry, oil industry, and things like that. And that is where the bulk of the tubular structures, at least that I know of in Western countries, they use. And from personal experience, at least in Singapore, which heavily depends on the tubular structure kind of construction and offshore industry. They do a lot of work, and a company that's called Kepler, I think, is one of the leading offshore industries. They have actually done a lot of work, and it is very, very common. Tubular structures in offshore industry is very common. I think he had told about the painting that would prevent corrosion. But one thing you can be sure, the reason is that since it's away in the sea, the wind is a major culprit. So the direction of wind is very different, and you do not predict the direction of the wind. And so tubular structure comes in handy because there is something called force coefficient. The force coefficient is very low when you have a tubular structure because it does not attract the wind. The wind force is generated by the force that is acting perpendicular to the direction. So when it is a surface section, it does not attract much of a load. And so it is one of the most preferred cross sections, tubular sections in oil industries. Thank you.
Thank you so much, sir. Anyone else? Any more questions? Okay, so with this, this brings us to the end of the year, and before we wrap, ladies and gentlemen, we have a few of our esteemed guests who actually joined us for this evening, and it's a moment to thank them. And for the same, I request Mr. Anubhav Gupta to please join us on the stage. Presenting token of thanks to Dr. Vinod Jain. Can we all please put our hands together? Request Mr. Karan Agarwal to please join us. Mr. Akul Khanna.
Excuse me, sir. Excuse me, sir.
Mr. Pune Airport.
पीछे से पीछे तो पीछे फटाफट
Please, yes.
Can you hands to read Singh? Can you put your hands together?
On behalf of all the attendees attendees here. Yes, yes. Thank you so much.
Joshi.
Thanks, Elena.
Chandra Ashok. Vinod Jain. Can you all please put your hands together? Rajiv Gupta. Rajiv Gupta. Kuldeep Panchal. Akul Khanna. Okay, that brings us to the end, and with this, again, closing remarks, let me hand it over one more time to Mr. Gupta.
Thanks everyone for being here. It was a real pleasure to have this session, and now allow us to host you for dinner and coffee. Thank you so much. Please join us.
Thank you so much. Once again, thanks to each one of you for taking out your precious time from your busy schedules. Please join us for cocktail.